All right, so I think I'm recording. Let's take a look here. What we're doing in these problems is matching the equation to its appropriate graph, and we've been using function transformations on a parent function on the graph of A and shifting it left or right or up or down or stretching, shrinking, or doing reflections. And for number 17, it is one of those transformations. However, many of you would have to remember your Algebra 2 days and remember properties of logarithms, which, we have not reviewed yet. So I'm going to do this number 17 a little bit more like I did the original problem in number 10. I'm going to create a table and then look at the different points and pick the graph by using points in my table. And then I'll try to remind you of what this property is and to illustrate that it would be a lot easier if we could just jump straight to the property. So if I create a table of values of x and y, normally we just randomly pick various values in the domain and calculate the output. But for these log functions, if we rewrite this in exponential form, this 4 has an exponent of y, and this is equal to 1 over x, you're going to find it easier to construct this table if you plug in different values for y and find the appropriate x. So if I plug in negative 2 for y, on the left-hand side I have 1 over 16. So if I take the reciprocal, that'll be 16. If I plug in a negative 1 for y, on the left-hand side I have 1/4. And if 1/4 is equal to 1 over x, then x is equal to 4. By definition, 4 to the 0 power is 1, and 1 divided by 1 is 1. If I plug in 1 for y, I have 4. And if the reciprocal of x, if 1 over x is equal to 4, then x is equal to 1/4. And if y is 2, then 4 to the second power is 16. And if 1 over x is equal to 16, then x is equal to 1 over 16. So it's probably going to be easiest for us if we focus our attention on these 2 points, because we'll be able to find those. But let's make our own sketch over here to the side. It won't be drawn to scale, but it'll at least give me an idea of what to look for. So 1, 0 is the x-intercept. So if this is 1, then I know that my graph is going to pass through that point. 4, negative 1, well, 4 is to the right over here. So if I make it 4, and negative 1 is below the x-axis. So here's roughly the point 4, negative 1. Now 1/4, comma 1, 1/4 is just a little bit past the origin and up 1. So it's like about right there. This is not to scale. I'm just kind of eyeballing it. 1/16 is even closer to the origin than 1/4 was. And at 1/16, we're getting even closer there. And that 16 is going to be way off of these graphs, but it's far to the right here. And it would be only down to negative 2. So if I connect the dots here, I didn't connect the dots very well. It's hard to this is just a rough sketch. So I'm looking for a graph that looks like this, and it looks to be this F over here, looks to be the general shape, because let's come in and 1, 0, yes, it's passing through 1, 0, 4, negative 1, 4, negative 1, and you can see that as you're getting closer to the origin, as x is getting closer to 0, the y values are getting bigger. 1 and 2, here, and when x is 1/4, the y value is 1, and when x is 1/16, it's 2. So it's clear that our choice here is F. Now, had you remembered what the properties of the properties of logarithms were, it'd be a lot easier to recognize that this was a previous answer, that this was the same as that matches the same as the equation for problem number 11, I believe it was. But let's look here. We know that from properties of exponents that we can rewrite 1 over x as x to the negative first power. That you know that 1 over x to the first power, if I bring that base up to the numerator, I have to change the sign of the exponent. Negative exponents don't make your answer negative. It changes the location of that base within a fraction. Well, we have what we call the power rule for logarithms. And we haven't looked at this yet, but we soon will be. And that's that when you have an exponent, when you have a power, you can bring this -1 down out in front of this as a coefficient, as a multiplier. So if you take -1 and put it in front of this, it's -1 times log base 4 of x. And a lot of times, instead of writing -1, we just say the opposite. And if you look back at number 11, that's what problem number 11 was. And hopefully we matched it to the graph of f. So I hope that helps, and I'll talk to you later. It was a transformation. It was the same as a reflection across the x-axis. Hope that helps. Bye.